Hi there, Jim here. Today we're going to have a look at this large screen display smart digital multimeter. This one is not branded on the box outside, but this comes to me as a Proster FS999L unit. And the claim to fame of this unit, you can kind of see from the external of the box, is that it's got a huge LCD display. Most of the unit is an LCD display. So let's get in the box. Before we do that, I just want to mention that this unit comes to me for review through the Amazon Vine program. Now, if you found this video to be helpful, please give it a thumbs up, or better yet, subscribe to my channel. I appreciate any questions and comments you might have. They're always welcome. The feedback helps me know where I can focus my efforts. Let's get into the box. We see the unit here in some bubble wrap, so it's well protected. There's a screen protection film there. Some buttons on the side that we'll be looking into later. Clearly that's a power button on that side. There's a stand here. It's not clear where the charging is because this is supposed to be a rechargeable unit. Maybe it's back here. Oh yeah. So there's a socket for a USB charge cord there. And there's some spots here to plug in probes. What's interesting is that they've put a plug into one of the slots, not the other two. Maybe it fell out. This is a fairly short one. Usually they put much longer things in there. And in the other part of the box, there's a thermocouple for temperature measurements. Typical USB-A to USB-C cord for charging. A pair of probes. Let's just have a look at the probes for a second. So this feels like it's PVC. The probes are fairly narrow and fine. And they've got not a sharp tip. The cover might make you think that the tip was sharper, but not a sharp tip. And it's all a single unit. So you can't really interchange the ends here. Okay. And there's an instruction manual. And the instruction manual seems to cover a variety of different models. Well, actually, I think it's probably languages. So the English part of this manual is 11 pages long. So, and it's got a few other languages, German, French, Spanish, and Italian, if you're interested. So, a manual, but probably not a super complicated manual. And that's it. That's everything that's in the box. And so the next thing we are going to want to do, well, what we want to do is put the unit through its paces, but the next thing that we're going to do is charge this up. Let's have a look at what the display presents to us when we put it into charge mode. So the unit is now plugged in and charging, and the display doesn't show anything, but this LED at the top lights up and is red, and I expect it will change to green when the unit's finished charging. And so I'm just going to let that finish charging. The unit is now fully charged, and as expected, the LED glows green. And when I unplug the charge cord, it turns off. So this LED is only on, either red or green, when it's plugged in. Now I've plugged the probes in the common locations. I think this line here must indicate that that's where the red probe goes. That's the typical thing. And that must be where the common probe or the black probe goes. That's the typical thing there. And then this side is where you would plug in if you're measuring amperage. And so any amperage measurements will have to go to this side. And we can see, looking at the unit, it's a fairly clean unit. There are no controls on the front, unlike a typical multimeter that we might be experienced with and that we're going to do our head-to-head testing with, the Fluke, where there's a dial and a bunch of controls on the front. So now let's see what this looks like when we first turn it on. So turning it on is accomplished with this button on the side, and we have to hold it for a couple of seconds, and it comes on. And look at that. That is, I gotta say, that is one gorgeous display. That is an amazing display. It just looks fantastic. And now that the display is on, we have some indications here. This shows us that this socket down at the side here is used for diode check, frequency, Celsius, Fahrenheit, voltage, ohms, capacitance, and continuity. This is the common probe, and then this is the location where we plug in the probe for amperage. Now, it's in auto mode to begin with, and auto mode may not work that well for every single function, because in auto mode the unit has to kind of guess a little bit what functionality it's in, and it really can only guess between a couple of things. It can kind of guess voltage mode or resistance mode, but it can't really guess a lot of the other modes. And so operating in auto mode is not always the greatest thing to do with any multimeter. It seems convenient, but the multimeter doesn't perform so well because it has to spend some time determining what you're actually trying to measure. And so it's usually better to operate into a fixed mode. Let's have a look at what these buttons do. And so there's 3 buttons here. One of them is for capacitance mode, and then that symbol there is supposed to indicate that it controls the backlight of the display, but I've never been able to make it do anything because the display is an OLED display, or OLED type display, and so it's always emitting light, and so I don't see what the need is for a backlight, so that's a little bit weird. This button does data hold and flashlight, and so if we hold this button down, you can see a little symbol comes up on the display there, and if you can see, the flashlight is on. Okay, and another long press there turns off the flashlight and the symbol goes away, not surprisingly. And then this button here is for going out of the auto selection modes, but it also turns on a laser pointer. So that's a new thing for me for a multimeter. It's kind of cool to have a multimeter with a laser pointer. Very neat. There is no symbol, though, interestingly enough. There's no symbol that appears on the display indicating that the laser pointer is on, like we did for the flashlight. So it's a little odd because it's kind of tricky sometimes to detect the laser pointer. Anyhow, we'll turn that off. And so the laser pointer is off now. And now, just before we get into a lot of things, we can see that we've got APO, means auto power off, and so if the multimeter is not being used, it'll turn off on its own. Auto switch means it'll attempt to automatically select modes, and I mentioned that that may not be the greatest way to operate a multimeter because it makes the modes that are automatically detectable operate more slowly, which might not be desirable. And then it shows the temperature down here just because there's a lot of space available to us. And so, and it tells us here, for example, that we've got 6,000 counts. So now let's see what we can do here. And we're going to be going head to head with this Fluke in terms of determining how accurate and how performative this unit is. I've had some feedback from some of the viewers on the channel, and they want me to try to make measurements in parallel. In other words, instead of taking a reading for the voltage with one of the meters and then taking a reading for voltage with the other meter, they want to see them side by side, and they want to see both readings at the same time. And so for some of the things like voltage and current, perhaps that's possible, but it's not possible for all of the settings. So we can't do resistance in parallel. We can't do the continuity in parallel, wouldn't make sense. We can't do the capacitance in parallel and things like that. But for the settings where that is possible, AC DC voltage and AC and DC current, they would like to see that the readings done at the same time and just be able to see side by side exactly what the meters are showing. And so you'll see a little bit of extra wiring here in order to enable that sort of behavior. And as I mentioned, I'm going to put the unit into voltage mode. So that's diode check now. That's resistance, continuity, non-contact voltage, live wire detection, temperature, frequency. So that's DC amps, AC amps, and that's DC voltage. Okay, so that's DC voltage now. And I'm not going to do that for every one of the settings, but just to show how we cycle through with that function button. We'll put the Fluke into DC voltage as well. And I'm going to be testing the voltage of this lithium-ion battery pack. One of the things to notice is that with the probes open, the voltage on the Proster is jumping around like mad because it's attempting to measure millivolts. And so with the open circuit there, it's just kind of jumping around like crazy. If I put the probes together, I get 0 volts, and so that's what we'd expect. And similarly on the Fluke, there's a little bit of noise there, but if I put the probes together, that's what I expect, 0. Now, I wanted to measure voltage with both of these units in parallel, and one of the things that I noticed as I began to measure the voltage is that when I put the Proster into the voltage mode as opposed to the auto selection mode, aside from the fact that it's sort of dancing around, it's gone into millivolt mode, and I can't seem to figure out any way to get it from millivolt mode to regular volts. And so if I just measure right now in millivolts, the Fluke is in volts because it doesn't have a millivolt range. But if I measure now, you'll see that the Proster, it immediately goes over range, and the Fluke, as long as I can get these things in contact, right? The Fluke is showing 16.3, roughly 25, whatever, jumping around, but it's showing about 16 volts, which is what we'd expect for the 4 lithium batteries. So what I've got to do with this Proster in order to measure voltage is I've got to put it into auto mode, because there's no other way to get regular voltage because it won't auto range. So now it's in auto mode, and I'm just going to now measure the voltage here with the probes on the 2 items. So we see that it's off by 1/100th of a volt compared to the Fluke. But I want you to look at the amount of time that it takes in auto mode for the unit to measure, right? The Fluke is pretty quick, whereas it takes quite a while for the Proster to figure out what mode it should be in and what range it should be in order to do that measurement. The measurement itself is accurate enough. I don't think that the difference there in the tenths of a volt, in the hundredths of a volt really is going to make much of a difference. So that's a bit of a disappointment. I'm hooked up now for AC voltage with a lot of wires all over the place in order to be able to do the parallel measurement. You can see that the Fluke is kind of jumping around a little bit. The Proster is having a hard time because the power's not on. Let me turn the power on now. And so we see the 2 meters now are reading about 124 volts. The Proster is about 0.3 of a volt different from the Fluke. Once again, I don't think that the 0.3 of a volt is a big deal, but I want to pay attention again to what happens when I turn the power on. So the Fluke's got the reading there, now the Proster's got the reading. So it does take a while for the Proster to figure out what's going on. It does figure out what's going on, and it does it correctly, and we've got a good AC voltage reading. This is all in auto mode, and kind of a handy thing with the way the Proster works, I can also get the frequency readout here at the same time. So 59.96 hertz, it's expected to generally be 60 hertz, so that's pretty close to 60 hertz. I'd be pretty comfortable with that. But the issue really is the amount of time it takes because you're forced to operate in auto mode in order to do that measurement. So it does take a while. Now let's look at a few other measurements. In order to remove the effects of handshake, meaning my shaky hands, I'm going to be using some alligator clips connected to the probes in order to do the measurement. Now, for resistance, I'm just going to short these together, and you can see that there's about 1.3 ohms of resistance that the Fluke is registering just for the test setup I've got here. So about 1.3 ohms of the resistance here is coming from the test setup itself. So that's resistance with the Fluke, 151.2. Resistance with the Proster, having the Proster in manual mode. It takes a while, but it comes to 150.9. Pretty close. But do notice the amount of time it takes, and this is not an auto mode. When we do that with the Fluke is a fair bit faster to figure out the resistance. Continuity is one of my favorite tests. So we're going to look at continuity here in the Proster, first with auto mode. So quick taps are not responding. So really, you've got to be in contact for a while. Now, let's see if we can put continuity into a manual mode. There we go. So there's a manual continuity mode. Much faster. Not perfect, but quite a lot faster. So in manual mode, the Proster has some nice operation on continuity. If you've been watching some of my videos, you know the Fluke is just awesome in this regard. The Fluke never misses a beat. And I have to say the Proster is almost the equivalent of the Fluke in this manual mode. Very nice. Diode check for the Fluke. Quickly determines the forward voltage drop of 213 millivolts. Diode check for the Proster. .233 millivolts. But it doesn't beep. And that can be a bit of an annoyance when what you're trying to do is test a circuit. That beep can be very handy. So no beep on the Proster for diode check. I have here an electrolytic capacitor that's rated at 1000 microfarads, and we're going to try that out. Capacitance on the Fluke. .991, pretty close to 1000. Now 968, 72. So it jumps a little bit. One more time. 975, 972. So that's, the Fluke seems to settle into about 971, 972 for its view of capacitance. Capacitance on the Proster. .929, 942, 48, 59, 60, 61. So reads a bit lower than the Fluke, but it does take a while to stabilize, and it does take a while for it to get to that reading in the first place. Let's try that one more time, and let's pay attention to when I put the clip on. .968, so a better reading this time, but it really does take, and now 973, closer to what the Fluke was reading, but it takes quite a long time for the Proster to measure the capacitance. That's pretty slow in my book. Non-contact voltage detection, the Fluke tends to be extremely sensitive. You can see the Fluke is sensing that power cord way out here. That's in high sensitivity mode. The Fluke also has a low sensitivity mode. So the range button changes to low sensitivity mode. And you can see that in low sensitivity mode, I've almost got to get right on top of it. The Proster does not have any different range selection here. It's all automated. Oh, and I've got to be pretty much right on top of the sensor. The sensor's over here. So if we're right on top of the sensor, it reads. Out here, no reading. So we do get a reading, so that's good. But you have to really be along this axis with the sensor, because out here, no reading out here. The non-contact voltage, functional, but maybe not as sensitive as we would like to see, because it would be tricky to get into an electrical outlet with something that's sort of blunt like that doesn't have a huge amount of sensitivity. Now we're going to try the hot wire detection, and hot wire detection is not a feature of the Fluke. The Fluke doesn't have that capability. Now, live wire detection on the Proster, the live wire detection is done using the red probe, and so we're going to check for seeing which of the pins here is the live wire. So let's try the ground pin. Well, that's a surprise, because that should not do that. That's the neutral pin. That should not do that. And this is the true live pin here on the left. And it sounds too. And so the Proster is telling me all of these are live. Now that's not true. The old-fashioned way to do this, to figure out which of these is a live pin if you don't have a live detection, is to put the black pin into ground, and then one of these pins will read a little bit of voltage and one will read 120 properly. So if we go and we're looking at the Fluke now, if we look here, we see that we're not really seeing any voltage because we're looking at the neutral to ground. So we're not seeing any real voltage there, just a tiny bit. If we go into this pin, we see we get 124 volts. So that's telling us that this is the live pin. And I would expect that with the Proster, the only way that we should be getting a signal is by inserting into this pin here. And so we do get a signal from that pin, but we also get a signal on this pin and a signal on that pin. So the live wire detection is just completely non-functional. Now, similar to what was done for the voltage, where I had both units in parallel, I'm running for a current measurement, I'm running both of these together as well. We have a circuit here that's feeding 5 volts in through that 150 ohm resistor, and so we should see a current reading of about 30 milliamps is what we would expect in that circuit. So we've got 5 volts and a resistance of 150 ohms. We should get about a 33 milliamp resistance if we do our Ohm's law calculations. Let's look at what we actually do get. And so we can see that both of the units are reading pretty much the same. They're reading generally about 30 milliamps. Now, I expect that we're seeing some loss in terms of the expected value. There we go to 31 milliamps. We're probably seeing some loss just because of the running the current through all of the meters at the same time. And so I think if I were to use one of these independently, I would probably see something closer to 31 or 32 milliamps is what I've generally seen in the past. But there we go, 31 milliamps. And so I think that you can see they're both pretty responsive, and they're generally reading pretty much the same value in terms of milliamps. Now, the one thing I'll mention is that the Fluke is auto-ranging in this mode, whereas the Proster has gone into milliamp mode. And I don't know, and I don't really want to do a setup with a high level of current, but I'm concerned that the Proster might be stuck in that milliamp range, and there's not a way to get it out of the range, just like it kind of got stuck in millivolts, and it didn't get out of the millivolt range in order to measure voltage. I could only do that through the auto mode. Well, there you have it. That takes us to the end. You have seen the sort of side-by-side, head-to-head comparison between the Fluke here and the Proster FS999L. And I've got to say, the Proster has a gorgeous display. It's got a really cool feature with that laser, but when it comes to the overall functionality of the unit, the live detection was just non-functional out of the box. So that was a real disappointment that the live wire detection is not working. And then some of the other features, like the capacitance, are just incredibly, incredibly slow in order to operate. On top of that, the voltage detection you have to be in auto mode in order to do voltage detection properly, because if you try to go into manual mode, where these units usually are more responsive, in manual selection defaults to millivolts, and there's no way to get it out of millivolt mode so that it can also measure volts. That's another kind of shortcoming of this unit, because it wants to be in auto mode. And as we saw with the continuity in auto mode was kind of slow, a little pokey, you wouldn't want to use it there, but continuity in the dedicated continuity mode was just fantastic. Another shortcoming of the unit is the lack of any sort of audible signal in diode detection, in diode check mode. The diode check mode works reasonably okay, except without that audible signal, you'd have to keep glancing over from wherever you've got your probes on the board over to the meter to determine whether it's checked the value. And of course, the forward bias voltage on most diodes is usually pretty much the same. You're not looking to diode check mode to figure out the forward bias voltage most of the time. You're looking to diode check mode to ensure that those diodes are still working as expected. And you don't want to have to keep glancing at the screen in order to do that. So that's another shortcoming. So overall, I have to say that because of some of the shortcomings in this meter, despite the gorgeous display, I wouldn't really be able to recommend this unit. Sorry to say. If you found this video to be useful, please give it a thumbs up, or subscribe to my channel, or better yet, do both. And until next time.